This presentation is brought to you by the Freedom team at Astronics Test Systems. Our goal is to introduce you to the latest addition to the R8000 product family, the Freedom R8200, the ultra-portable LMR/PMR test solution for subscriber and infrastructure testing. Since the R8000 was first introduced in 2009, this family of software-defined LMR test equipment has grown to support not only the shop and field segment, but also manufacturing as well as site installation and maintenance segments. The R8000 has evolved through 3 models, making it a solid, reliable choice for bench and light field work. The R8100 added an internal swappable lithium-ion battery, among several other field-centric improvements. It has quickly become the field technician's tool of choice. The R8600 adds 150-watt, 100% duty cycle, 24/7 operation to support radio manufacturing and large service organizations. The R8200 adds a high-performance VNA to become the only instrument needed for site installation and maintenance. The Freedom R8200 builds on a shared platform of hardware and software products, solutions, and tools. The addition of this 4th hardware product to the family leverages the vast ecosystem of advanced capabilities and tool sets developed over the past decade. From LMR digital protocol support to auto-tune subscriber radio test and alignment, from network remote control to point-and-click script creation, every customer's instrument has continued to improve and gain new capabilities. All firmware is backwards compatible back to the very first unit that rolled off the production line over 10 years ago. Perhaps even more importantly, these tools are backed by a world-class service and support team with unequaled turnaround time and unrivaled access to subject matter experts. At the local level, customers are supported by the industry's best manufacturers' representatives and distributors. The Freedom R8200 combines all these innovations together with exciting new capabilities utilizing its new built-in vector network analyzer hardware. This new hardware adds only about 1 pound or half a kilogram to the weight of the unit and fits within the same form factor as the R8100. This is a true marvel of modern engineering. No functionality was removed. All the same analog and digital instruments and capabilities are still included. The Freedom R8200 is an all-inclusive, full-featured service monitor able to handle signals up to 150 watts and generating low-level signals down to -130 dBm with plus or minus 1 dB accuracy. Every aspect of this family's features that customers have come to rely on are there and ready to use. The Freedom R8200, innovation without compromise. Ultra portable is the only way to describe this instrument. The Freedom R8200 is light and fast. Its small 15-pound package, less than 7 kilograms, makes it easy to carry anywhere and get into any small space. No need for a cumbersome external return loss bridge or multi-piece calibration kit. Pressed for time? It's fully operational in 90 seconds, able to switch from analog to digital modes back and forth nearly instantaneously, and it loads pre-configured presets in 30 seconds. This instrument is designed for the RF technician who needs to get the job done fast and accurately, so he can grab it and go. The Freedom R8200 is a high-performance instrument with features and specifications to prove it. Sweep the RF spectrum as wide as you want, no limits, and find those weak signals with a noise floor down to -140 dBm. Keep an eye on the RF spectrum and modulation at the same time. The dual display gives you simultaneous views of the frequency and time domains. Drastically cut down time required to test and align subscriber radios. AutoTune automates the process reliably and repeatably. Free your technicians to do other work. We've included advanced features as part of the standard configuration. Control the instrument at a tower site over the network from your office. Create time and money saving scripts to automate routine testing using a simple point-and-click PC software. This is just a sample of the features and specs that set the Freedom R8200 apart as the best tool for LMR/PMR radio test. The Freedom R8200 from Astronics Test Systems represents a major step in the evolution of land mobile radio test. The Freedom R8200 is the first and only test instrument that combines comprehensive digital and analog LMR testing with the ability to measure important RF network characteristics such as distance default, return loss, and voltage standing wave ratio, or VSWR. The Freedom R8200 is also the only service monitor with the ability to display advanced RF parameters on a Smith chart for more advanced network analysis. The Freedom R8200 VNA is a one-port VNA. The instrument generates a sweeping signal into the device under test, or DUT, and measures the magnitude and phase of the reflected signal. The magnitude measurements are displayed as return loss or voltage standing wave ratio, which are the most common LMR measurements. Phase will be displayed in degrees and also visualized on the Smith chart. In the context of the Freedom R8200, the tracking generator is the tool to use when you want to look at a signal transmitted through an RF device, such as a duplexer. The VNA is the tool you want to use when you want to measure the complex impedance reflected by an RF component, such as a cable or antenna. With this deeper understanding of the Freedom R8200's VNA functionality and performance, it should be clear to customers who are responsible for site installation and maintenance that the R8200 is able to meet all test equipment needs at the site. It's no longer necessary to carry one instrument for testing the radio equipment and one to test the network infrastructure such as cables, adapters, lightning arresters, and antennas. The Freedom R8200 is capable of supporting the verification and documentation of all the critical components in the system. The Freedom R8200 accurately measures the base station's transmitted signal and displays the frequency error, output power level, and signal deviation in one easy-to-read screen. The instrument precisely measures the receiver's sensitivity as well as other important site characteristics. The Freedom R8200 tracking generator and VNA make it possible to tune RF filtering portions of the system for maximum performance. Its large dynamic range and high RF generate output will provide a clear image of the deepest notch on multi-cavity duplexers. The VNA assures the technician that the insertion loss is completely minimized. The powerful marker functionality and screenshot capability makes performance documentation simple and easy. Finally, the Freedom R8200's VNA pinpoints potential transmission infrastructure problems quickly and nearly instantaneously. Whether you're looking for bad or loose RF connectors, broken solder joints, kinked, crushed, or cut cables, water ingress or corrosion, poorly tuned or damaged antennas, shorted lightning arresters. Find any of these impairments with no external equipment before they impact the system. Know within inches where the issue is located before you try swapping components or sending a tower crew up the tower for a visual inspection or repair. All of this powerful functionality is offered in an instrument with a short learning curve. Over 10 years of customer feedback provide a clear picture. The Freedom R8000 products are easy to learn, easy to use, intuitive, and responsive. Thousands of RF technicians around the world use these instruments every day and prefer the Freedom R8000 products over all the other options they have tried. In the second half of this presentation, we'll take a closer look at the Freedom R8200's VNA tools available in the initial release of the instrument's firmware. We'll start with the return loss and VSWR plot. The return loss and VSWR application allows a user to view the quality of matching of transmission in the system across frequency. Both return loss and VSWR are conveniently displayed on a single screen. Multiple markers may be placed and measured against a reference marker to determine relative match performance across frequency. The FREEDOM R8200 VNA's return loss and VSWR plots measure reflected signal levels over frequency. This type of measurement is the key to testing, aligning, and documenting antennas, RF filters, and cable loss. The FREEDOM R8200 return loss and VSWR plots must be set up to achieve a balance of accuracy and speed. Setup parameters and their impacts on accuracy and speed are discussed next. Higher level output allows the VNA to more accurately measure low-level reflected signals, such as when you have a good match. However, in some situations, the high power level may introduce crosstalk or interference into the system. In these situations, the output level should be set to low. Increasing the number of points swept by the VNA increases the resolution, but also increases the sweep time. The IF bandwidth should be set before sweeping, as any changes will require the VNA to be recalibrated. By decreasing the bandwidth, less noise is captured in the signal measurement, which lowers the noise floor. The added resolution will make it possible to better distinguish between adjacent sweep points that might otherwise blend together. However, this increased resolution also comes with a cost of increased sweep time. Averaging lowers the noise by time averaging each sweep point with the same point in previous sweeps. The longer the averaging count, the less responsive the trace will be to sudden changes in level. So, keep this in mind, as this could be detrimental when looking for intermittent issues. The last parameter is smoothing. Rather than time averaging, this parameter averages adjacent points in each sweep, providing a smoother trace. This will improve the readability of the plot, especially for documentation purposes, but it is at the expense of resolution. Keep in mind that important data points indicating potential issues may be easier to overlook. Each parameter provides great control to maximize the effectiveness of the tool, but must be balanced according to the needs of the application. The two traces can be scaled automatically or manually to view an area of interest. Traces can be set to update continuously or freeze to catch intermittent issues, or only sweep once to capture a screenshot for documentation purposes. A future firmware update will add the ability to save and recall traces and overlay them for analysis. Remember, firmware upgrades are free of charge and are available on the FREEDOM website. Your instrument just keeps getting better over time. Your investment is future-proof. Up to 6 markers are available for each trace, for a total of 12 markers. These markers can display absolute measurements or measurements relative to a reference marker. Markers can be placed at user-specified frequencies or placed visually by scrolling or jumping between peaks and valleys. The user can even tell the system what constitutes a peak or valley by specifying an excursion value. You can skip over small peaks or valleys and jump between tall peaks and valleys. The FREEDOM R8200 VNA's next tool is the distance default. The distance default application sweeps the response of a system versus frequency and, via transform domain analysis, determines the distance to the mismatches along the transmission line. Cable properties such as velocity factor and frequency-dependent loss values can be entered manually or recalled from a library of standard cable types. The user can zoom into segments of the transmission lines of interest. Also, sweep settings can be adjusted to coincide with a frequency range of interest. Multiple markers may be placed on the trace to accurately identify the location of anomalies and their magnitudes. The FREEDOM R8200 VNA's distance default tool measures reflected signal level over distance. This type of measurement is the key to sweeping cable runs to identify the location of suspected faults. Using the system settings, Potential faults can be evaluated by magnitude and failure mode. Locate opens, shorts, kinks, corrosion, water ingress, loose connectors, human or animal-caused damage. The FREEDOM R8200 VNA's distance default tool is a frequency domain reflectometer, or FDR. This is a sophisticated tool which provides major improvements over the older time domain reflectometer, or TDR, which used DC pulses and were primarily used to locate catastrophic failures such as opens and shorts in your cables. The FDR sweeps the cable over its operational frequency range and measures the return loss. The data is then processed to present loss over distance. The user selects the distance units of measure of feet or meters. The user tells the instrument how far down the cable to sweep. This is typically set to a value just longer than the approximated length of the cable. Once the cable is swept, the user can focus on a cable segment that may show a potential issue by setting the start and stop distances. The FREEDOM R8200 VNA's distance default tool converts the frequency data to time data and equates the time value with distance. To do this accurately, the instrument must be given two important parameters to define the properties of the cable. The velocity factor indicates the speed at which signals travel down the cable. This is defined as a percentage of the speed of light. The smaller the cross-sectional dimensions of the cable, the lower this value will be. This parameter makes it possible to accurately convert time data to distance data with extreme accuracy. The cable loss parameter allows the tool to adjust the displayed return loss value to compensate for cable loss at a distance. As an example, an antenna at the end of a cable might have a measured return loss of minus 35 dB when measured from the far end of the cable, but the instrument calculates that the cable has 5 dB of loss for that length of cable and displays a return loss value of minus 25 to account for this cable loss. For the 5 dB of signal that's lost before the signal reaches the antenna, and the 5 dB of signal lost when the reflected signal travels back towards the instrument. Both velocity factor and cable loss are a function of the materials and design of the cable and can be found in the cable manufacturer's datasheet. However, for the user's convenience, the FREEDOM R8200 provides a library of commonly used LMR cable types. The user can also add cable definitions to this library. The transformation algorithm that takes the frequency domain data and turns it into time domain data can be adjusted by the user to achieve different views. This parameter is called response type. When set to bandpass, the data is presented in true FDR mode. The user sets the center frequency to the center frequency of the operational band. The cable is swept and its performance in that band are presented as return loss. Low-pass processing presents the data in a way that relates more closely to what you would see with a TDR. The user selects either impulse or step response based on the need or preference. The impulse view peaks up and down based on the capacitive or inductance nature of the fault. The step response is the integral of the impulse response and relates to the impedance of the cable. The trace will rise or fall based on the impedance of each cable segment. With experience, the user will learn which response type best suits each situation. As with the previous tools, measurement accuracy and speed must be balanced to meet the needs of the situation. Let's take another look at the relevant parameters for the distance default tool. This tool has three main parameters. Higher output level allows the VNA to more accurately measure low-level signals. However, in some situations, the high power level may introduce crosstalk or interference into the system. In these situations, the output level should be set to low. Increasing the number of points swept by the VNA increases the resolution, but also increases the sweep time. The IF bandwidth should be set before sweeping, as any changes will require the VNA to be recalibrated. By decreasing the bandwidth, less noise is captured in the signal measurement, which effectively lowers the noise floor. The added resolution will make it possible to better distinguish between adjacent sweep points that might otherwise blend together. However, this increased resolution also comes with the cost of increased sweep time. As with the return loss VSWR plots, each parameter provides great control to maximize the effectiveness of the tool, but they must be balanced according to the needs of the situation. The FREEDOM R8200 VNA's distance default application produces a single trace. This trace can be scaled automatically or manually to view an area of interest. The trace can be set to update continuously or freeze to catch an intermittent issue, or only sweep once to capture a screenshot for documentation purposes. Up to 6 markers are available for this single trace. These markers can display absolute measurements or measurements relative to a reference marker. Markers can be placed at user-specified distances or placed visually by scrolling or jumping between peaks and valleys. And again, the user can tell the system what constitutes a peak or a valley by specifying an excursion value. The FREEDOM R8200 VNA's next tool is the Smith chart. The Smith chart displays both magnitude and phase over a swept frequency range. The x-axis represents the purely resistive load, with 50 ohms being at the center. A short circuit is indicated where the x-axis meets the outer circle on the left. The far right intercept is an open circuit. Points above the axis are inductive. Points below are capacitive. Solving complex impedance matching issues becomes much easier when both magnitude and phase can be measured across a range of frequencies. A future update will enable multiple markers to be placed on the trace to display magnitude and phase at several specific frequencies. The FREEDOM R8200 VNA's impressive measurement accuracy is maximized by a user calibration which compensates for test cable and adapter impedance characteristics. In the VNA terminology, this process moves the measuring plane to the edge of the actual device under test. For example, if testing an RF filter, the user calibration will remove the impact of the test cable that connects the instrument to the filter. The calibration process is straightforward and involves attaching a single-piece open short load calibration kit where the device under test will be connected. After each termination is made, the user tells the unit to gather the calibration data for that particular step. The instrument will indicate that it has acquired the needed data. When a system parameter is changed in the plots or distance default, that potentially invalidates the calibration, and so the instrument displays a calibration status warning to remind the user to recalibrate the VNA. For the ultimate accuracy, a user can provide information about the calibration kit to compensate for its slight impedance mismatches. There's no such thing as a perfect open or short or load. The calibration kit's manufacturer provides a datasheet with all the relevant parameters. The FREEDOM R8200 provides a library for the most commonly used calibration kits, including the one that is included with the instrument. However, the user can add a custom cal kit to the library for later reference. With open short load user calibration and calibration kit compensation, the FREEDOM R8200 provides the tools to make extremely accurate VNA measurements. In summary, this presentation has demonstrated that the FREEDOM R8200 truly is the ultra-portable LMR-PMR test solution for subscriber and infrastructure testing. The FREEDOM R8200 is the full-featured, all-in-one test solution most trusted by radio technicians across the globe. The FREEDOM R8200's high-performance, no-compromise VNA is ready for your site installation and maintenance needs. For additional information, please find the following overview and datasheet documents in the document library on the FREEDOM website. That's freedomcte.com/library. Please check our website for product information such as data sheets, brochures, operators manuals, user guides, application notes, and other videos. Contact information for our sales and application engineers is on the support page. To schedule a product demonstration or to obtain pricing information, contact your local U.S. manufacturer's representative or international distributor. You can also connect with us through social media channels. On behalf of the Freedom team at Astronics Test Systems, we trust you have found this presentation useful and hope you will reach out to us and let us show you how our expertise, our experience, and our products can save you time and money as you endeavor to keep the radio communications flowing on your systems.